A kite is another type of quadrilateral that has the following three properties. It has two pairs of consecutive sides that are congruent. And remember, consecutive means next to each other. And so those sides that are congruent are these two sides next to each other and these two sides next to each other. It also has one pair and only one pair of opposite angles that are congruent, and those angles have to be the ones that are connecting the non-congruent sides. We have our two pairs of consecutive sides that are congruent, and the angles that are congruent are the ones that connect those two sides that are not congruent. These are the two angles that are congruent. And last but not least, the diagonals of a kite are always perpendicular. So if we mark our diagonals in our kite, they cross each other at a 90-degree angle. They are perpendicular. So let's look at some examples. In example 5, we're supposed to solve for x and y. X and y are parts of the expressions that describe our four angles. So let's get started. The only angle measure we're really given is this angle with 135 degrees, but we know that the angle across from it has to be congruent. We just learned that about kites. So let's use this piece of information and find out what x is. 2x plus 1 is equal to 135. So I'm subtracting 1. 2x is equal to 134. Divide by 2. And x is equal to 67. In order to find y, we have to find the measurements of the two remaining angles, but these two angles are not congruent. So we can't take those two expressions and set them equal to each other. We have to use a different property of quadrilaterals, and that is the sum of all the interior angles. And if you remember from the previous unit, in a quadrilateral, the sum of the interior angles is equal to 360 degrees. And why don't we take a moment and write this down here so we remember it better. All four angles together have to add up to 360 degrees. So we have y plus 6 plus 5y plus 135, and our other angle that we found before also has to be equal to 135, and all this together is equal to 360. So let's combine like terms. All our y's together are 6y, and all our constants together are 276. That's equal to 360. So I'm going to subtract 276. 6y is equal to 84. Now dividing by 6, we get y is equal to 14. And on we go to the last example of the day. Find the missing side lengths of the kite MATH. In this kite, we're given the diagonals with the lengths of their segments, and remember that diagonals in a kite intersect each other at a right angle. They are perpendicular, and we have to find the side lengths. Now, the side lengths are part of a different polygon, and that's a triangle. If you look at this, this is a triangle, and it happens to be a right triangle, of which we know two sides, which are parts of the diagonals. And if we know two sides of a right triangle and we're supposed to find the third side, what do? of course, we're going to use our Pythagorean theorem. C squared is equal to a squared plus b squared. C squared refers to our hypotenuse, which is the side of our kite. So c squared is equal to 5 squared plus 8 squared, which is 25 plus 64. C squared is equal to 89. That means that c has to be equal to the square root of 89. Now, we can either show this as a decimal, punching it into the calculator, or we can show it as a simplified radical. Is there anything that we can take out of our 89? As it happens, there isn't. So the length of segment AT is square root of 89, and that happens to be the same as the length of segment HT. And we can do the same to find our other missing side of the kite. This is part of another triangle, which is also a right triangle. This one here. So in this case, c squared is equal to 6 squared plus 5 squared, which is 36 plus 25. And that happens to be 61. So c is equal to the square root of 61. Square root of 61 can't be simplified either. So segments MH as well as segment MA are equal to the square root of 61. Alright, we did it. That's it for today, you guys, and I will see you in class.